So we're going to try this one out. And so we have this diagram. We've got two infinitely long lines of charge with plus and minus, and they're separated at distance d. There's a lot of measurements. All of this is symbolic, right? So the one thing we have to remember when we're doing symbolic stuff is that you have to have your answer in terms of these things, d, q, p, not so much. Okay, eta, also negative, but that's kind of the same thing. Okay, so the first thing we want to do is draw this out. So we have the infinitely long, I guess we could just copy and paste this guy.
That works.
Make him bigger. Now he's kind of blurry. Okay, so the first thing we want to do is remember what are the electric fields of these things, right?
Are you talking about like the way that they're pointing?
No, so we know for a point charge, right?
Yeah.
So point charge, oh, that's too fat. Gotta get a smaller pen, okay. So electric fields we know. Okay, so for a point charge, what's the electric field?
Is it the 1 over 4 pi epsilon naught?
Yeah, the KQ.
Okay, yeah.
KQ over R squared with
Yep.
the R hat.
Mm-hmm.
Okay, that's the point charge. We have an infinite line, right?
Mm-hmm.
What's that?
Is that the... Oh, let me see. I have it written down somewhere. Is it that, like, L something? No. Maybe that's for doing stuff.
2K lambda over R.
Yeah, that sounds right.
Also in the R hat direction, but remember
I wrote it down 2K lambda over X.
The point charge looks like this, right? Where this is electric field lines, which are sort of, this is a cartoon version, and then the infinite line, right?
Mm-hmm.
They sort of stick out in all directions, like this.
Yeah.
And then there should be one over here, like there. This is not a great drawing, but you get the idea. It should go out radially in all directions.
Okay.
Oh, that one's weird. Okay. Stop it. Sometimes the pen gets mad. Okay. And then, so that's your electric field for the line charge. And then the last one is the infinite sheet of charge. So, sorry, I just have to say that.
Every time.
Yeah. And that's going to be, that's one is eta over 2 epsilon naught.
That sounds right. Let's see here.
It's not a memorizing class, but sometimes it's important to remember some things.
Yeah, I know. But when there's so much to remember...
There is a lot to remember. And that's why I don't make you memorize. But it does speed things up if you can remember a few of these things.
Mm-hmm.
I try to memorize by the way of just doing way too many problems.
Yeah, because I wrote a lot of this stuff down. It's just figuring out where it goes, which is what I was telling him.
Just FYI, we're going through this problem and I'm recording it so I can post it. So you will be recorded if you say something. Okay, so those are our different electric fields for the objects that we have here. Okay. And what we kind of want to do with that is we know that, so we both need these distances, right? Because a lot of these depend on R. This doesn't depend on R, but this does, right? Mm-hmm. So this one has a distance, which we don't know, unfortunately. Actually, let me draw it from the center to P. This one has a distance D, 2D, right? This should have the same distance as the other guy. And we know these distances are D, right? So that's 2D. So this is 2D. This one we're going to need Pythagorean Theorem, right? Mm-hmm. So that's going to be the square root of 2D squared plus, I'm going to do this over here.
D squared plus 2D squared.
Yeah, so the square root of D squared plus 2D squared
That's it.
which gives us
Oh, there's a chair right here.
5d squared.
Okay.
Which should be the same as 5 root d. Is that right? That's 5 root d. Oh no. D root 5. Root 5d. Okay. And this, do you know, why does this distance not matter right here? Oops.
Is it because it's an infinite sheet?
Infinite sheet, right?
Yeah.
So it doesn't depend on distance. So these are our r's for different things.
Okay.
So then the distances matter, but then we also need to know the electric field vectors because they're going to add or subtract because they're vectors. So this is an annoying vector problem. The positive one should have a vector that points this way. So this is for E plus lambda. Okay. The negative one should have one that points along the line. So that should be E minus lambda because it's an attractive
Force.
electric field. Yeah, attractive force, but so then an attractive field. And then this one should point this way. So this is E Q. And then from the infinite sheet, it should point this way, right?
Like away from it or towards it, I guess.
Yeah. I'll just call that E eta.
Okay.
Okay. Do we feel confident about that?
Yes.
Okay.
Because I have those little tiny lines. I drew those. And then the 5D, the root 5D I didn't do because I just put the thing there. I knew that's what I wanted to get, but I didn't know how to get it, I guess, or maybe, I don't know. But I didn't draw the charges or I wrote down the plus or minus lambda and all that good stuff, but I didn't actually label it or anything like that. So.
Okay, so I'm gonna just match these over here. So these go with the infinite line, right? And I'll just do that one in blue, and then we'll put that there too. And then the point charge we'll do as orange, I guess. And then the infinite sheet will make pink. Oh, that's annoying. I could have done that better, but so it's a lot of coloring. Okay. Okay. So can you see right away one way to make this simpler?
Well, I figured that some of them cancel each other out because it's the same distance.
Yeah, so that if we wanted to combine these guys, then when you add them up, let me change to a pink color. You're going to end up with 2 E lambda in the y direction.
Okay.
Which, yeah, that's probably a better way to write that, but you get the idea.
Which one are you combining? The plus and
So
minus?
this one should, these guys
Okay.
should have equal and opposite, right, x components, and then the same y component. So we just take the y component and double it, and we know it points down. So that means we're kind of getting rid of these. So then we just have 3 vectors we have to calculate, and then we have to add up those 3 vectors. So when we do that, we know EQ, which should be in the x direction, right, is going to be K, Q, and what's R in this case?
Is that 2D?
Yeah, that's 2D. So then we just do 2D, and we square it, and that should be in the positive x hat direction. Okay, just looking at this, you can tell it's going to be in the positive x hat direction.
Yeah.
Then E eta, right? That's from that guy. So that's going to be eta over, well, that one's just eta over 2 epsilon naught, so that's easy. I hate drawing eta. It's like a stupid n.
And you said for the infinite sheet, the distance doesn't matter, right? So you don't have to put D under there.
Right. There's no D, no D here, so you don't have to include it. And so the key here is noticing that this is in the negative x direction. So when we add these two together, we have to subtract. Okay. And then in our y direction, that would be E lambda. E lambda is this infinite line, so that's 2k lambda over r, which in this case is square root of 5d.
Okay.
Right?
Yeah.
However, we want that to be just the y component. So how would we get this to be just the y component? Because what we really want is 2e lambda in the y direction. That's what we decided this was.
Mm-hmm. Would you want to? Are you isolating for lambda? Or?
Well, so we'd have to figure out the x and so if we look at this one, right, we want to figure out the well, actually, yeah, like this. This one, this vector should have an x and y. This is just back to physics 201, x and y component.
Yep.
So what we need is this. This angle, right? That's theta.
Okay.
So to get this y direction, we need this to be sine of theta, and then this goes in the y hat direction.
Okay.
And it's going to be the negative y hat direction just by looking at the problem. However, we don't have theta as one of our givens from the problem, so we have to figure out what sine of theta is. Well, we know that theta should be this theta, and we know the adjacent and the hypotenuse and the opposite. So this is d, right? So sine theta should be d over root 5d, which gives us, really, is it really that simple? All right, I haven't done this problem in a while. Hope I'm not screwing this up.
No, that's right.
You right? Okay. So then to get the full thing, right, we actually want to multiply this by 2. So this becomes 2e lambda in the y direction. And that's a vector. It doesn't really need to be a vector because you already said it's in the y direction. So you're, anyway, just semantics. So this becomes 4k lambda over root 5 because we multiplied this 2 by 2 d. And then this becomes 1 over root 5. And then this is in the y hat direction. We'll pull the negative out here. And then there's a little extra thing you can do where this becomes 4/5 k lambda over d in the y hat direction. Okay, so when we add these, so E total, oh gosh, we're running out of space. Let me make this smaller. Oh no. Okay, so I'm gonna move this over here. That we can get rid of. All right, so here's all, make it a little bigger so people can see it. So our E total, I'm going to move it. Sorry. This is what I think about when I write problems. E total is just adding up basically, you know, this, and this. Or I guess more specifically, let me just pick up color. We need to add up this, this, and this. Now you notice these two are in the x direction, so we can just add those. Although it's not pretty. So you'll end up with, because we have stuff in the x and y direction, so if you want to leave it in vector form, which is the cheater way of doing it, but is a delightful way of doing it, you want to say, okay, you have kq, and I guess I'll simplify that to 4d squared minus eta over 2 epsilon naught, because you can't really simplify this crap. Right, and that's in the x hat direction.
Okay.
Sorry, my hat is stupid. Okay, and then you add, we'll basically subtract 4/5 k lambda over d in the y hat direction. Now, I'm actually okay with leaving it like that because there's nothing really to be gained by plugging this crap into Pythagorean Theorem and a tan inverse because it's just going to be ugly. But if you really wanted to do that, so this is perfectly okay as an answer as far as I'm concerned. In fact, it's easier for me to read than whatever crazy nonsense. But if it were numbers, oh, that's cool. I didn't know. It's just, okay. If it were numbers to get the angle and whatever, you'd have to do like E total magnitude is equal to square root of this squared plus this squared. But I don't want to do that. So we're just not going to do it. I don't even know what the answer looked like in the solutions, but hopefully it was this.
Yeah.
Okay.
Sure it was.
Okay.
I don't know yet.
So that's perfectly okay. And this is vector notation. And if you deal with like semantic math professors, they'll want this in I hat and J hat. But I don't understand why we need I to map to X. Like we know it's in the X direction. We just put a hat on it. We know it's the unit vector. It's not like we don't use enough different variables.
Exactly.
Yeah. Okay. So that's problem 1. Thanks for watching.